Hello, I am Saurabh Saxena and I am discussing about the data structures. So data structure is basically how we are storing, how we are accessing the data. So data is nothing but it's a raw fact, and structure is in a particular format, in particular layout, we are storing and accessing the data. So depending on the practical implementation and the requirements, we have the different type of data structures as first is array, second is stack, then queue, linked list, tree, and graph. So first I will discuss about the array. Array is a collection of same type of element in a sequential manner. Means if we are using the array, then elements are stored in a sequence. Like suppose this is a memory, a common name, suppose A is given, and this memory is divided into different partitions depending on the size of array. And these memories locations are having an index. So 0 is the starting index, 0, 1 up to n minus 1, that is the index of array. Okay, so the address of first location, that is A0, is called the base address, and then the address of any other location can be easily calculated by the compiler by using the formulas, and there is no need of searching each and every locations separately. So in a sequential manner, we can access the elements in an array. Second is the concept of stack. Now stack follows the principle of LIFO, that is last in, first out. Means the element or the data that is stored at last will be the first to get accessed. So we can see the application of stack in our email, in our inbox. The latest mail is displayed at the top of the list, at the top of the inbox. Similarly, in the WhatsApp or in messages, the latest messages are seen first. So that is implemented by using the stack, last in, first out. Then we have the concept of queue. Queue follows the principle of FIFO, that is first in and first out. So queue are implemented in various applications. Like suppose if we are printing the documents on a single printer by using a single system, then the document that will be given first for printing will get first to get printed. Okay, so means a queue, a pool is maintained by the compiler, by the system, for all the documents that are there for printing. Okay, then we have the concept of linked list. So the limitation of arrays, if we don't have the memory, a chunk of memory available in the system as a whole, but we have the memory at a distinct location. Suppose I have memory here, 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 at the different places. Okay, so we can store the elements in different memories, but because the memory is not available as a chunk, so we can't store the data in the form of array by using the arrays. Because for array, the memory should be available as a chunk. So to overcome this location, this condition, we use the concept of linked list. Means we just store the elements at discrete locations, and then we just make a link for accessing the element. Like suppose I make a link from this to this, then this to this element, and this to this element. Means the sequence is this element will get first, then this element will be accessed, then this element, and then this element. Okay, so by using the links, we can frame the sequence of execution of the data. Next comes the tree. The tree data structure is used when we want to store the elements in a form of hierarchy. Like suppose in an organization, there is an owner. Under the company owner, we have different directors, suppose, or different presidents. Then under these, we are having some GMs, AGMs, etc. Okay, so means in this way, if we want to store the data in a hierarchical form, then we use the tree, because in tree we have the parent-child relationship. The topmost element is called the root, and then it is said to be the left child of the parent, and it is set to the right side of the parent. Okay. Similarly, we can extend the level of the tree as per the requirement of parent and child relation. And the last one is the graph. Graph is very important because graph is used in all of the social media sites. And in graph, the concept is we have the isolated elements, and any element can be connected to any other element. Means we have m into n cardinality. Means m elements can be connected to n elements. Like suppose in FB, these are FB users. Okay. So if this user send request to this user, then they become friend. Now this user send request to this user, it become friend. They become friend. These two are friends. These two can be friend. These two can be friends. Okay. So means any m elements can be connected to n elements that are in the system. Okay. So that is the concept of graph. Means every node can connect it to and other nodes in the system depending on the links, depending on the linkage that we are going to create. Like in case of Facebook, if we send a request to someone who is on the Facebook, then only we become a friend. Otherwise, the users are different. There are n number of users in the system, but they all are isolated users. They are not interlinked until we create the link. Until your friend request is accepted, you are not a friend. Okay. So and second thing, you can send request to any user on the Facebook. Okay. So means the accessibility of all the data is for all the nodes. Means any node can access any other node in the system, but the links can be created only when there is a relation between the nodes or between the data. Otherwise, all the nodes are isolated and they are stored in the memory. So these are some data structures. Next is why we use data structure, because we want to access the data in a particular format. Depending on the requirement, depending on the situation, we can use stack, we can use queue, we can use tree, we can use graph to access the element. Now, what are the operations that we can do on data? We can create, we can store the data, we can search any data, we can sort the data, we can modify the data. So whatever operations are there that we can apply on data, we can apply all of them on all these types of data structures. So this is about the data structures. Thank you.